Hello, welcome back to SN Tutors. Today we're going to be doing acetal formation. Okay, so the overall reaction looks like this. You have a carbonyl, in this case a ketone, and you have a diol, and you treat it with acid, usually H2SO4, and you end up with this, which is called, So this right here is your acetal. So how does this happen? Well, it's acidic conditions. So the first thing you always do in acidic conditions is you protonate. This is sort of a long mechanism, so I'm going to try and run through it pretty fast for you guys. Feel free to rewind if something goes by too quickly. So you end up with a more reactive carbonyl, right? So right here, it's protonated. Don't forget your formal charge. Now, our nucleophile, which is this up here, is now strong enough to come in and react, attack that carbon there, swing these electrons up, because it's protonated now. So we end up with this. There's this oxygen right here, and then this is right here, but we still have this H attached. So we got the positive charge on there. So then we get a base, generic base comes in, takes the proton. And now it's neutral. And now we want this to leave, right? Because in the final product, both of these oxygens are attached, and this original oxygen is not. So what we do is, since it's acidic conditions, we have to protonate it before it could leave, because you can't have any negative charges in an acidic environment. OH will not leave in an acidic environment because it would be OH minus once it leaves. So that's why you have to protonate it, and then it'll be neutral water when it leaves. But before it leaves, it's going to be positively charged. That's how you get it reactive enough to leave in this environment. Right? So now it's protonated. Boom, boom. Right there. Okay, now it could leave. So this is an SN1 reaction. However, you always have to draw the best resonance contributor, right? So you show the electrons going away, but then this would just be a carbocation right here. So what you need to do is you need to show these electrons going down to stabilize that carbocation. Right, so now water is gone, and we just have this. Oxygen with 3 bonds is positively charged. Boom. Now this one is reactive enough to come in and attack, pretty much. So now this one gets neutralized, but this oxygen now has a positive charge because now this one has 3 bonds. This one right here. So you have one to hydrogen, and then one to carbon, and one to another carbon. Positive charge. So then our base comes in, takes it, neutralize. That's the final step. And our final product, try to draw neatly, is this acetal right here. All right, well, thank you guys for watching this video. Please let me know if you have any questions. See you next time.